So hey guys, welcome back to my channel, and today we will be discussing another question from GATE 2025. And the question says, a computer has two processors, M1 and M2, four processes P1, P2, P3, P4 with CPU bursts of 20, 16, 25 and 10 milliseconds respectively arrive at the same time, and these are the only processes in the system. Scheduler uses non-preemptive priority scheduling with priorities decided. M1 uses priority execution for the processes as P1, P3, P2, P4. That is, P1 and P4 have the highest and lowest priorities, respectively. And M2 uses priority execution as P2, P3, P4, P1. And P2 and P1 have the highest and lowest priorities, respectively. As process Pi is scheduled to a processor Mk, if the processor is free and no other process Pj is waiting with higher priority, at any given point of time, a process can be allocated to any one of the free processors without violating the execution of the priority rules. Ignore the context switch time. So we are not taking into the account the time that will be consumed by context switch. Now we will have to tell the average waiting time of the process in the milliseconds. So given that at t equals to 0, processes P1, P2, P3, P3 and P4 arrive in the system. And now we have CPU1 and CPU2, or better said M1 and M2 processors. Okay, so in the so obviously at t equals to 0, we would be having P1 and P2 starting to run initially. So P1 M1 will start running P1 while M2 will start running P2. Now since the burst time for P1 is 20 and P2 is 16, so from t equal to 0 to t equals to 20, P1 will be running on processor M1, while from t equals to 0 to t equals to 16, process P2 will be running. Now, after P2, the process that has the highest priority is P3. Then the P3 and P4 that were initially waiting till t equal to 16, all the other processes that are P3 and P4 are waiting. So P3 gets scheduled on M2 to run. So from t equals to 16, 41, P3 P3 would be running on M2. Now at t equals to 20, we would see an important thing, that since P3 has already started running on M2, we would now move on to the process that is after P3 in the priority order, which would be P2. But since P2 has already completed before t equals to 20, we would move to the other one, that is P4. So now, since P4's burst is of 10 milliseconds, it will start at t equal to 20 and it will run till t equals to 30 on the processor M1. Now to calculate the wait time, we have to average wait time. What we have to do is subtract the starting time of the process from its arrival time. Arrival time minus start time. And it's summation because we are doing it for all the processes. And this would be mod p. This means the cardinality or the number of processes that we have. And this is for each process belongs to the set of processes we are calculating this time. So this will give us the average wait time. Now for process P1, if we see the arrival time was 0 milliseconds and the start time is also 0 milliseconds. So 0 minus 0. And as for P2, if we say arrival time and start time are again 0 and 0. Now if we move on to P3, the arrival time, you better take the absolute value of this. So it would rather be start time and arrival. So the start time of P3 is 16 while the arrival time is 0 seconds, 0 milliseconds. And now when we move on to process 4, the start time is T equals to 20 milliseconds and the arrival time is 0. And now if we divide this by 4, that is the total number of processes, we would be getting 36 by 4, that is average of 9 milliseconds of wait time. So from this, we can see option A is clearly the correct answer. So thanks for watching this video. If you found what I shared as valuable, do share it with your friends and people who are interested in